Hi everyone, in this video we're going to be looking at solving radical equations. This is section 2.3 of your textbook and it's outcome R13. Alright, so the first example we're going to look at is we're going to solve this following equation algebraically. So you did a little bit of this in grade 11, a bit of a different form of this. So here we've got the square root of x plus 4, and that's equal to 3. And we have to figure out what the values of x are that are going to satisfy this equation. If you were savvy enough, you could look and just guess what the answer is going to be. So you want this square root to end up being 3. So what answer is going to make the stuff under the square root 9? Well, 5 is going to do that, but let's say it's more complicated. We need an algebraic approach to actually figure it out. So here you've got the square root of x plus 4. That's equal to 3. First thing we're going to do is we're going to square both sides to eliminate the square root sign there. So that essentially it's the opposite operation. So it goes away. We end up with x plus 4, and that is equal to 9. Solving for x, subtract 4 on both sides, we end up with x equals 5. Alright, so the thing here is you have to always make sure that you isolate the radicals before you do any algebraic manipulation, okay? Now, here we are also going to look at the restriction. So what are the restrictions on the domain here? Well, we know that anything under the square root has to be larger or equal to 0. So that tells us that x always has to be greater than or equal to -4 for this case. Now, let's say we wanted to do it graphically. We're going to turn this into an equation. So we're going to move everything over onto one side, and we're going to make it equal to y. Now it looks like the radicals that we've been graphing before. So from the original parent square root, so if we were to look at this as the parent, how has this been transformed? So we're moving 4 to the left and we're moving down 3. So this would be what our graph would look like. So our radical would start here and then it would go here. So this is what we're looking for as our solution. Okay, it's the value of x. We want to know where does our graph cross the x-axis. Okay, all we care about is the value of x for the solution to these types of equations. Okay, so if you notice, it matches this answer that we got above. Alright, now graphically the solution is the 0 of the function, since taking the original equation and setting it equal to 0 is how we found the above equation. So that's what we did, move the 3 over, make it equal to 0, and then turn it into equation by setting it equal to y. So just note that the zeros, roots, and x-intercepts of a function all represent the same thing, the place where the function crosses the x-axis. This also represents the solutions to the equation. So whenever you're asked to solve radical equations, that's what you're looking for. We don't want the y value, we don't want a point, we just want the x value. Alright, so now let's solve this one algebraically first, and then we'll have a look at the graph and we'll see what's going on. So the radical is already isolated, it's already on one side of the equal sign, so I'm going to square both sides and end up with x plus 5 on that side, and then make sure that when you're squaring this, you do it properly, write out the x minus 1 twice. So I've got x plus 5 equals x squared minus 2x plus 1. Move everything over to one side of the equal sign, and then you're going to get it equal to 0. So you end up getting 0 equals x squared minus 3x minus 4. And then you're going to have to factor this. So we've got 0 equals x minus 4, x plus 1. Set each of these equal to 0, and then you're going to solve for x. So you go 0 equals x minus 4, and 0 equals x plus 1. So in this case, x is equal to 4, And for this one, x is equal to negative 1. Okay, now there's something important that you need to do. Now notice how we've squared both sides, so that could potentially create extra answers that weren't originally in our equation up here. So we must verify your solution with the original equation. Okay, you must do this. They will take marks off if you don't do this, all right? They're looking for the actual verification. It can be something very quickly done, but you must do it. So take the original equation. So let's first verify x equals 4. And you want x plus square root of x plus 5, and then x minus 1. Put in the 4 where the x's are, and just make sure that they are equal. So that's good. Now let's verify x equals negative 1. So take the original equation and put a negative 1 in where the x's are. Alright, so right here we end up with a problem. Notice how you've got square root of 4, which is 2, and then you've got this negative 2 on this side. These are not equal. This is impossible. Okay, so you must reject x equal negative 1. So over here, you must show that that is not a solution. Not a solution. Okay, and you must show that this verifies. So that's good. All right, so the solutions that don't work out, those are called extraneous. So the ones that don't work out are extra, in other words. Okay, so x minus 1 is extraneous. All right. I'll write that there so that makes a little more sense. Sorry about the mess. Okay, so now let's do this graphically. So I've got this already graphed for you. I've separated them into two different pieces. You've got the graph of x, this is a graph of square root of x plus 5, and then this is the graph of the right-hand side, which is x minus 1. Now what we're looking for here is we're looking for where these two intersect. So we're just looking for the x value of where they intersect. So that's at x equals 4. All right. Now, you can see that on this graph, it doesn't intersect anywhere else. There is no possible way that it could intersect at x equals negative 1. Do you see this right here? So it's definitely not a solution. Okay. Now let's look at the next question. So here we're going to follow the exact same process. How about you press pause and you try this question before moving on. Okay, so I'm going to square both sides, so I get 2x squared plus 1 equals x squared plus 2x plus 1. X squared minus 2x equals 0. Move everything over to one side. Factor. Set each bracket equal to 0. So here x is equal to 0, obviously. Here x is equal to 2. Now verify both. Okay, and then you get the square root of 1 is equal to 1, 1 is equal to 1. That works, that checks out, that's good. Now let's check our other one. That's all under the square root sign. Make sure you extend it so that it looks like it's all under the square root sign. And here we end up getting 3 equals 3. So both x equals 0 and x equals 2 are solutions. Okay, so let's look at it graphically now. Graphically, this is the graph of the square root of 2x squared plus 1. This is the graph of x plus 1 right here, and we want these two x values. So here x equals 0, and right here x is equal to 2. And those are our solutions, which verify exactly with what we just did above. Okay, now these are a couple of questions for you. I'm going to leave these for you to do, and I want you to bring them to class. Okay, so give them your attempt. I'm not going to show it to you on the video, and then we'll discuss these questions, look at them, and have a look at the homework as well. All right, thanks for coming out. Enjoy.